Okay, the first thing I think I'd like to do is just get the point of intersection and the problem. And kind of looking at it, I think one thing I do is take the second equation and solve it for y. And what I mean by that is y equals minus 2x. Very simple problem, by the way. It should be a line that goes through the origin with a slope minus 2. And then I would take this y equals minus 2x and plug into the first equation. And let's do that. What do you get? You would get x equals, well, it's going to be y cubed, which is going to be minus 8x cubed. And then it's going to be minus 18y, and that's going to be plus 36 x. Let's see if I did that right. Minus 18 times 2, yeah, 36. All right? So I'm going to rewrite a little differently. I'm going to write it as 8x cubed. Let's see, minus 35x equals 0. I'm going to factor this. X comes out. And what are you left off with? Looks like you're left off with 8x squared minus 35 equals 0. So there's three solutions to the problem. One of the solutions would be x equals 0. The other solution would be where x is equal to, let's be careful here, it's going to be the root of, let's see, 35 over 8. And the other one's going to be x equals minus root 35 over 8. All right? Now, granted, I think I get somewhat of a picture of this thing now. And what I mean by that, I can sort of get there. I know points of intersection look kind of crazy looking, but I do know that this sort of looks like this over here. And that's this thing graphed. This guy here, relatively simple. What do you mean by that? Numbers aren't nice, but I get x equals, and a y comes out, and you would get y squared minus 18. So you get plus or minus root 18. And this thing, just simple graph over here, would look sort of like this. All right? But it's not accurately drawn, by the way, but there's symmetry to the problem. And I got, the points of intersection now. All right? I got the 0, I got this number, I got that number. And what I want to do is, I just want to do one of those sections. I want to do this section here. And I want to point out, looking at the symmetry of the problem, that this section over here would be identical. So what I want to do is write it down. And what's it going to look like? Well, the differential is going to be dy. My limits of integration, we're going to be starting here, and this is along the y-axis. So we're going to go from 0. This point over here is where x equals minus 35 over, oops, I made a mistake there. Copied wrong. It's minus the root of 35 But what I want to do is get the y value. It's minus 2 times that, so it's going to be 2 root 35 And now I got to put this, the rectangle down. And the rectangle is going to be that line, which is, minus 1/2 of the y. I'm looking at this. Minus this guy, which can be minus y cubed, and minus a minus 18 is plus 18. All right, what I would do now is look at the integration. Oh, there's 2 of these things, by the way. I'll put this over here. I want to see if I got it. Did I get the proper integration? Oh, I highlighted this before. Let me get rid of that. I have the 2. I have the 0. I've got this, and I've got this. I didn't simplify. They didn't simplify what I did, and I'm looking at this, and I'm looking at theirs, and there's certainly a difference between the two. And let me go through that. So let's write this down. 2, 35 over 8. Just like you did in math when I'm going to try to make the bottom a perfect square by multiplying top bottom by 2. And when you get 2, this would be 70 over 16. The square root of 16 is 4. This would be 2 root 70. And 2 goes into 2 once, goes into 4 twice. So root 70 over 2. Let me get my eraser out. and say this probably looks better as root 70 over 2. All right, I got the integration, and now what are you going to do? You're actually going to do the integral, right? You're going to do that integration. Okay, let me get the eraser out, erase this business over here, erase my highlighting, and my next goal is to simplify the integrand to see if I can integrate. And let's go for that. And let's take a look at that. I'm going to distribute the 2 on the inside. And you get 0 root 70 over 2. This would be minus y, minus 2y cubed plus 36y dy. Let me keep going. That would be 0 root 70 over 2. You get 35y minus 2y cubed dy. I'm actually going to do the integration now. What do you get? You would get 35y squared over 2 minus, that would be y4, divide by 4, we have 2 on top, so we give me a 2 there. And we're going to go from 0 to root 70 over 2. And we got to do some arithmetic here, don't we? And this looks tough. Let's write this down. 35 over 2. And when you square root 70, you would get 70. And when you square the 2, you get 4. Minus, fourth power. So that's going to be 70 squared. And that's going to be what? 2 raised to the 5th power, which is 32. All right? I got a lot of arithmetic here, don't I? And what I'm going to do is I'm going to try to reduce it. 2 goes into 2 once, goes into 70 35 times. All right, let's keep going. What do you get over here? 35 squared over 4 minus, I'm going to simplify this too. Just too much work for me. So what I'm going to do is, I realize it's 70 times 70. Let's see if I did that right. Yep. And then 32, I'm going to say is really 2 times 2 times 8. And 2 goes into this 35 times, goes into this 35 times. What do you get? 35 squared over 8. I got some work there, don't I? So the common denominator would be 8. And what do you get there? You would get 4. Let's see if I did that. 2. I'm sorry, 2 minus 1, which is 1, so 35 squared. All right, put a box in that. I do see that answer. I do say they also did some arithmetic. Let me put that down for you. 5 times 5 is 25. 5 times 3 is 15, 16, 17. 15, 9, 10, 5. Let's see, 5 and 7 is 12. 2, 1, 2, 2, 5. Yep, I'm agreeing with it. This is good news. We got it. Thank you.